this component is connected to the engine and can move freely without affecting the gearbox. As for the second component is the inner hub, which when attached is directly connected to the input shaft. As we can see, when this component is rotated, the input shaft in the transmission also rotates. In this condition, the clutch basket and the inner hub can move independently. We need a hypothetical connector between the clutch basket and the inner hub to transmit the rotation from the crankshaft to the gearbox. When this hypothetical connector is engaged and start working, rotational energy from the crankshaft is transferred to the input shaft of the gearbox. Then, when the hypothetical connector is disengaged, the connection of energy or rotation is interrupted and both components move independently again. Well, that's how the inner hub and clutch basket work. However, here we encounter an issue, that rotation from the engine can only be transmitted when the engine is at a standstill or turned off. If the engine is running, we will have difficulty re-engaging the hypothetical connector because of the challenge of aligning the positions of the clutch basket, inner hub, and the connector. To address this issue, engineers redesigned the hypothetical connector to make it work as intended. That is, intending to transmit and interrupt the rotation from the engine to the gearbox without removing the hypothetical connector component. This condition was realized by splitting the hypothetical connector into two different parts. First, the friction plate, which functions to grip and lock onto the clutch basket. And upon closer inspection, this component also has a rough section on its surface. The second is the steel plate. This plate has a teeth or spline on its inner area, which lock the rotation on the inner hub to the input shaft in the gearbox. Both components function as the hypothetical connector by clamping between the rough surface friction plate and the steel plate,